So I'm really excited about the speaker lineup we've got this morning. This year we decided to focus our Agritech Week event on precision crop nutrition. This is really topical at the moment. Increasing fertiliser use efficiency and producing more crop with less fertiliser inputs is one of the key ways we can reduce our environmental footprint of agriculture and take steps towards achieving net zero. The recent hike in energy prices is also having major knock-on effects, as I'm sure we all know, in fertiliser supplies and prices, and has also helped focus everyone's mind on their fertiliser inputs. So our first presentation is from Mechteld Blake-Kalff from Hillcourt Farm Research on improving nitrogen use efficiency by measuring additionally available N from mineralisation. Clive Blacker from Map of Ag will then discuss how fertiliser use efficiency measures can provide a new metric for fertiliser performance. Then we've got Kate Storer from ADAS. She'll present results from new research on the effect of little and often nitrogen and sulphur applications on yield, quality and nitrogen fertiliser uptake of winter wheat. David Booty from OMEX will discuss practical methods to improve nutrient use efficiency. And then finally, we've got Dan Kindred from ADAS, who'll cover tools to help us decide how much to apply. Just a reminder to post questions for our speakers in the chat. You can also use this chat function as chat, so as well as questions, we'd encourage you to share your own comments or experiences. So now I'd like to pass over to Mechteld for her presentation.
Okay, good morning everyone, and thank you, Lizzie. With the sky-high fertilizer prices, as Lizzie's already mentioned, everybody is focusing on how to reduce their nitrogen inputs. And one of the way, a good starting point is to look at your soils and to see how much is already there and measure your soil nitrogen supply. Now, soil nitrogen supply consists of three components. The first one is your soil mineral nitrogen, which is the nitrogen directly available for crop uptake at the time of sampling, and it's also prone to leaching and it can be immobilized. The second component is your crop nitrogen, which is the nitrogen that has been taken up by the crop during the autumn and the winter. And once it's in the crop, it's not going to go anywhere. And lastly, you have the additionally available nitrogen, which is the nitrogen that will become available between the time of sampling and harvest through the mineralization of organic matter. And it's this latter component that I want to talk about today, because it's something that is often ignored or forgotten about. Okay, I had quite nice slides that flashed in, but that doesn't seem to work. But anyway, so why is the additionally available nitrogen ignored? Unfortunately, RB209 itself is a little bit dismissive about it. It just spends one paragraph where it basically says, oh, it's very difficult to get reliable estimate when you have a low organic matter, less than 4%, it's negligible. And it's only really worthwhile if you have a very large amount of organic material put into the, put in your ground. Well, I would like to dispute that, because first of all, is it difficult? Well, we have been working for probably 17, 18 years now and developed the CF and MIN test, which does measure the additionally available nitrogen as well as your soil mineral nitrogen. And we know that we get the soil nitrogen supply in the right ballpark. So it can be done. Secondly, is the AAN minimal below 4% organic matter? Well, no, not really. We don't find that in our data. You find that, yes, additionally available nitrogen increases with the quantity of organic matter, but it also greatly depends on the quality of organic matter. So the carbon to nitrogen ratio of the organic matter, which is basically how easily it is digestible for the microbes. And we find that with a given amount of organic matter, there is a whole range of different values of additionally available nitrogen that you can have depending on the quality. And so we find more than half our of our sample is actually above 4%, but of those 89% of samples has got at least 20 kilograms of additionally available nitrogen, which at current fertilizer prices is worth £34.80 per hectare. So the test I want to talk about is nothing new, but what is new is that over the last 5 years or so, we have seen a very clear trend in farmers and agronomists thinking about their soil, putting their soil at the heart of their production and thinking about soil health and measures to improve that. And so a lot of farmers have introduced different practices on the farm to increase organic matter. There's far more use of organic manures or compost. Some people introduce short-term grasslands in the rotation, or they've reintroduced livestock. The use of cover crops has become more or less mainstream now. Nearly everybody is at least thinking about cover crops. And then there's the whole movement of regenerative agriculture, whatever you want to call it, but the added bonus of doing all these things, which are very beneficial for your soil health, is that you also are building up your stock of additionally available nitrogen. So the reward for your hard work in building up your soil health is that you're actually getting free nitrogen. Right, so CF fertilizers have done a lot of trials. Now, I realize some people might have knocked CF fertilizer off their Christmas card list this year, but you have to give them credit that they have always been extremely supportive of trying to get farmers to measure their soil nitrogen supply accurately so that they only apply the right amount of fertilizer, even if that's a little bit against their own aim of selling as much fertilizer as possible. So this year is the same. They've done a lot of tramline experiments to optimize the nitrogen use for farmers. And this is one of the experiments is that this is about 30 farmers or so, where the farmers have done their farm practice, which is what they normally always do, and then they have done on part of the field the CF and min test, and then they have followed the recommendation. It comes with a recommendation and where it calculates how much fertilizer it suggests you should add. And when you look at this graph, this is the yields, and the blue bars are farm practice, the orange ones are when you use CF and min recommendation. And the first thing you say, well, there's no difference at all. And that is actually a good thing, because the difference isn't in the yield. The difference is by the fact that, for example, this farmer here applied 65 kilograms nitrogen less per hectare. That farmer applied 50 kilograms less. This farmer here applied 38 kilograms less. And it's not that the CF and min test always recommends to apply less fertilizer. Sometimes it tells you to apply a little bit more, but where it's used appropriately in the fields where you expect that there might be high levels of mineralisation, possible mineralisation, in those fields, the average recommended reduction in fertilizer for farmers was 42 kilograms per nitrogen per hectare. And that, of course, brings quite big savings, as you can see. So what does that do to the nitrogen fertilizer use efficiency? So nitrogen use, fertilizer use efficiency basically means that how much of your fertilizer that you apply gets actually taken up in your crop and how much gets wasted. And the general assumption is that that in say 60% is generally taken up by the crop and 40% is wasted. Now, in this graph, if you look at the change in your nitrogen fertilizer use efficiency, where farmers have taken into account the additionally available nitrogen by using the CF and MIN test, you see most of the farmers have an increase in their nitrogen fertilizer use efficiency. So where it, for example, here says 20, it means that instead of 60% of your fertilizer went into your crop, 80% of your fertilizer went into the crop. These are real life farmers, so there are occasions where there was a reduction, and it's very important then to see why this is. And some of them, actually, the recommendation was to apply a little bit more fertilizer in those 3 points here, and the max, just a small amount, 20 kilograms, 16 and 5, but that didn't have an effect on the uptake, on the nitrogen fertilizer use efficiency. And these ones here was the yield was the same, but the nitrogen and crop offtake was less in the where the CF and MIN test was applied, and so there wasn't an increase in the fertilizer use efficiency. Another way of looking at it is to look at your nitrogen uptake efficiency, and this is where you look at how much the percentage of nitrogen in your crop as compared to your soil nitrogen supply plus your applied fertilizer, all the nitrogen that's potentially there. And again, you see that the nitrogen uptake efficiency improves if you do measure the additionally available nitrogen in the soil. And there's actually a specific reason for that, because the plant is not a passive vessel that sits there sucking up nitrogen. It's actually extremely complex process of regulation. It's very tightly regulated, and if you oversupply nitrogen, the first thing the plant will do is reduce its transporters on the roots. It will reduce the loading into the xylem, so to move the nitrogen from the root into the xylem, then up to the leaves, that will be reduced as well. And so per definition, if you oversupply your nitrogen, the plant will become inefficient. Whereas if you keep it just right, you don't want to starve the plant, but you want to keep it just a little bit on the hungry side, and then all the nitrogen transporters will be optimized and it will be working far more efficiently. Right, so this is a little bit a whirlwind explanation of why it's worthwhile to measure additionally available nitrogen, so it can help to reduce your fertilizer use and save money without compromising yield. I'm talked about quality, but it shouldn't compromise quality either. It improves your nitrogen fertilizer use efficiency and your nitrogen uptake efficiency, but it is important to pick your fields wisely. If you have a very degraded soil with a very low organic matter, it's probably not worthwhile. But wherever you are trying to improve your soil health, high organic matter, putting organic manures in after cover crops, after grass and leafy vegetables, then it's really worthwhile. And as we always say, you've got to measure it to manage it. And so this is where I suggest you start. Thank you.
That was brilliant. Thank you, Mechteld, and perfectly to time. This is a test, that, as you know, Mechteld, that we've used on some of our trials, so it's really interesting to get that background from you. We do have a couple of questions in the chat. The first one might be more of a comment, or if it isn't, it's very easy for you to answer. Bernard Martin's made a comment. He said he's old enough to remember the original soil mineral end test from ADAS, and it did try and estimate mineralisation. It was a very poor predictor. Have things improved?
Yes, yes, they have. And it's funny, there's always somebody who said, I used it 25 years ago and it didn't work. This is not it's not actually an estimation, it's actually a measurement. So what we do is we measure the we incubate the soil for a week in an incubator, and this process encourages, it sort of accelerates the whole process in a whole season in a week. And then we have done many balance experiments to say from what percentage of the total potential mineral nitrogen that could be there actually becomes realistically available for a growing season under UK weather conditions. So it's not an estimate, it's an actual measurement, and I think that's the difference.
Perfect, thank you. I've got a couple of more technical questions now. Herman Kruger has said, is actual moisture and temperature and yield potential of the season also taken into account? So very dry weather, lower yield, lower nitrogen needed.
Yes, so obviously the moisture and the temperature is very important for the actual mineralization, and the moisture is very important for getting it in the crop. So the test itself does include a modeling factor which takes into account the retentiveness of the soil. So there is actually, if you measure it in sort of January, February, it does sort of have a leaching factor included in the test. So it allows, if you have a heavy clay soil, is more retentive, for example, than a light soil. So there's a slightly different leaching factor. But at the end of the day, when it is dry, it doesn't matter if your nitrogen comes from fertilizer or from additional available nitrogen or from soil mineral nitrogen. It's just not going to go into the soil. That's just inherently a problem with drought. So.
Okay, thank you. We'll just try and quickly squeeze in this last question as well from David Clark. How often would you recommend resampling? Every sort of 3 to 5 years?
No, unfortunately, because soil mineral nitrogen is so very dynamic, you have to test every year. But the thing to do is to choose fields that are representative of a soil texture on your farm or a block of farm. So we don't recommend that you do the whole of your farm, but just to choose 2 or 3 fields which are representative for chunks of fields on your farm, and then use that sort of as a baseline for the rest of your farm.
Perfect. Thank you. Thank you very much for that. So now I'd like to invite our next speaker to join us. Clive, are you able to put your camera on?
Yeah, good morning.
Over to you.
Excellent. Well, thanks very much for the opportunity to talk to you today. So I'm just going to follow up from where Mechteld's left off and talk to you a little bit about how we've been helping growers to use or look at nitrogen use efficiency, and really start and think about how we can turn that on its head a little bit and use it as a metric for measurement. This is some work that I've been doing this year with Kellogg's Origins and equally on the farm at home. And what I'll explain is some of the tools we've used for nitrogen management and some of the challenges that we have and how we go about gathering the data that we need to make better decisions, how we're then manipulating the nitrogen rates, and then I'll give you some sort of take-home thoughts. Nitrogen use efficiency is something that is quite concerning to me because, you know, on average, 40% of what we apply is lost. The UK is typically only about 60 to 65% use efficient. And as a guy that's been involved in precision agriculture and certainly variable rate nitrogen applications for over 20 years, while we've shown great benefit from variable applications of nitrogen, I've never really studied, well, until about 5 years ago, the actual use efficiency of nitrogen. So being able to look at the use efficiency of nitrogen and understand that gave me different metrics on thinking about, well, how do we then apply nitrogen more effectively and take account of it? This year we've done some work with Kellogg's. We've had 4 growers, including, well, plus our own, where we've been working with EFFP, who've been helping facilitate the management and networking. And Kellogg's were really trying to look at how they can support their growers to produce better, higher quality products that can go into the food chain that actually don't have the same environmental footprint or impact, that we can actually reduce the deficits that we have and losses that we have. And of course, as farmers, what we're trying to achieve is the optimum application rates of fertiliser. And we've always been encouraged to look at this from a perspective of putting the right amount on to maximise and gain our optimum offtakes. You know, so without the optimum, we really struggle to get the best return from our nitrogen. As a result, then if we're not getting the best return, we're wasting it, and that's got two impacts. That's both financial to us, and equally it's also got impact to where we stand from a perspective of actually environmental losses as well. So we could be polluting the water, we could be polluting the air, and you know, with a week where we're in the middle of COP, then it's really important that we start thinking about the opportunity and the challenges about how we then reduce our liabilities from a carbon perspective and a greenhouse gas perspective. And what we've been doing with the project this year is looking at how we can then combine different data sources into our pure farming engine. And once we've got the available data from different sensors, whether that be satellite, whether that be ground sensors to look at soil moisture and soil temperature, looking at previous cropping and already applied nitrogen and other organic inputs to the fields, we can then use that data to start creating different benchmarks and different scales of analysis to not just inform the farmer, but also to help you make better decisions on when and how to apply your nitrogen. And the typical outputs that we've had from the data we're collecting is we're creating carbon benchmarks. We're creating an in-season decision support solution for farmers to be able to decide when to apply nitrogen and to time that accurately. And then finally, a field benchmarking tool that really allows us to get to the bottom of the data and interrogate the data in ways that we haven't been able to do in conventional agricultural software systems. So the first step is obviously learning where we started from. So the first step we did with Kellogg's this year was to benchmark the growers and their fields in the group. And we looked at comparing what they'd done in previous seasons, looking at their yield from each field, looking at the variable the inputs that they'd applied in terms of nitrogen to those fields, and then calculating an offtake. And then we present that data back to the farmers, and typically the red dotted line you can see on the bar graph there is the average use efficiency of the UK, and you can see some growers are very efficient, equally others are less so. So trying to then support how we can measure that. From a carbon perspective, then it's really important for us to be able to then explain to growers where the liabilities lie. And I don't know what it is about agriculture, but we seem to import our liabilities, but we aren't allowed to export them. So when we buy fertiliser, it comes with a carbon liability that we accept as farmers. So the first part of any solution is looking at how you purchase that nitrogen if you're wanting to reduce your nitrogen use efficiency, or offtakes, I mean. The second part of that is then the decisions we make as farmers to then apply nitrogen and how much of it we're applying and how efficiently the crop's then using that to take it away. And both of these are significant inputters to crop use efficiency. And you can see we've got different ranges in terms of CO2 release between 250 and 550 kilos of CO2 per tonne produced. And equally 1.8 to 4.1 kilos of CO2 per % of protein in the grain that's removed. So there's some quite drastic opportunities that we have as an industry to really improve what we can do by farming more efficiently with the right rates of nitrogen, taking into account variability within the season. So the way we started going about that is setting up some small plot trials or small plot test areas. So the methodology we're promoting is that let's start and do things very intensively in a small area of the field, but make sure it's a representative area. And try and do this in every field. And we did this across 16 fields at home on our farm this year. And the concept is that we would take an area that we think is representative of the field. We've then done our nitrogen assessment and measurements on those to do our soil mineral ends. We've put soil moisture and temperature probes in the ground so we can measure both down to 50 to 60 centimetres. And then within season, we've been using devices such as the end tester from Yara that give us the opportunity to actually measure what's going on in the plant as the plant's actually growing. So rather than doing a lot more additional testing that can be expensive through the lab, What this allows us to do is actually turn things on its head to use the plant as the sensor. And by taking regular readings, we can actually see what's going on with the plant, and it allows us the opportunity to then see when nitrogen uptake is occurring, how much has been taken up, and allow us then to address when to apply nitrogen and if it's ethical to do so. And this is just an example of the sort of outputs that we've had from this last season. This is showing us a number of different pieces of information. So we capture rainfall. That's the yellow triangles that you can see on the graphs. There's the blue lines, which are the actual kilos per nitrogen that we've applied and the dates the nitrogen's been applied on. And then the red line is actually the line of nitrogen uptake, or the nitrogen levels as measured by the end tester, taken from the crop, from the readings of the crop. And what's quite fascinating is that you can see crop levels declining. You can make applications, and you can see in this case we've made an application on the 22nd of April, and by the 25th we could see an impact to the crop. Now this graph was from 2020. This was 2 years ago. If you remember, we had a mild spring but very dry, and even with a little bit of rainfall, that was sufficient to allow that nitrogen we'd applied to be taken up by the crop. And you can see that the crop then once it got hold of that, started using it instantly. As more rainfall occurred, you can see there's a bit more nitrogen release that the plants can actually access. And 2 years ago, it was really, really dry, and we were having all sorts of challenges knowing how to apply our nitrogen that season. And one of the questions I regularly get asked is, if it's dry, how do I know that the variable rate technology I might be using is actually doing its job, and that we've actually taken the crop's taken the benefit up of the nitrogen that we've applied in a variable fashion. What was really interesting for me this year, and the take-home message I got this year, was obviously the impact of soil temperature. And we were in, again, quite a stressed season. We've had issues this year where, again, we had a very dry spring, but it was also a lot colder this year. And thinking about trying to understand as we start and grow more cover crops and trying different amendments to the soil to improve our organic status and try and sequester more carbon, then the challenge that we have is knowing when that available nitrogen is going to actually become available and taken up by the crop. And obviously, if we're doing that in a lab test, that's giving us some indication, but it doesn't actually tell us what's going on in the field. What was staggering this year was, even though we had a lot more moisture than we'd had in previous seasons during the grain season, we actually struggled to get nitrogen uptake to occur. And it was taking typically this year 22 days between nitrogen applications and uptake occurring, because of the limitations in soil temperature and the ability for plants then to be able to access the nitrogen in the right form that we've applied. And that was a real insight to how we then start and think about that this season, and take into account our soil temperature calculations to really help people and support them make better decisions. I'm not a fan of putting nitrogen on in conditions where the crop can't actually use it, and when it's more than environmentally susceptible to leaching and losses. So trying to get that timing right and trying to get it on in a position where the plant can use it will make the plant far more efficient. So what we've done then is, you can see we've put in this case, an average of 155 kilos of nitrogen we've applied to this crop. We can then look at that data, and then we can compare it then to the yield. And this is just an example of the dashboard in our phase 3, of where we're then creating dashboards to give growers the benefit of being able to target inputs and measure then the response and outputs at different scales. And what you can see here on this scale is we've got the yield of the crop, we've got a nitrogen use efficiency calculation, the ability then to look at our nitrogen offtakes and uptake measurements. But equally, we can then compare the different data sources and combine them statistically, so we can then look at where's having an influence. And if you notice, there's a graph on there with lots of dots in it in the middle. That's actually comparing yield to conductivity. And what that's showing me is, in some areas of the field where I've got very heavy soils, I've had limited uptake, where we got some waterlogging issues earlier in the autumn. But equally, on the lighter, sandier soils, we're also having uptake issues because they were droughting off. So trying to understand those areas and understanding exactly where they are will really help us, inform us when we start using the variable rate technology to calibrate those in such a way that we can then take account of that limited uptake capability and then applying more nitrogen. And the real benefit of this solution is then that we can actually get the data in our hands. Now, we are lucky enough to have a protein monitor on our combine, so we have the ability to be able to create nitrogen offtake data across the field from a yield perspective, a variable yield perspective, and equally a variable protein perspective. So it really does give us an opportunity in a very high resolution to be able to calculate our nitrogen use efficiency. The dashboard also provides us an opportunity to look at soil mineralised N. So if we know that we've taken up more from the soil, we can account for that and count then essentially our fertiliser use efficiency. And it's not always a rosy picture. In this case, this was comparing a field that we looked at into this year versus 2019. And you can see that while we haven't got a massive use efficiency, we're still up at 81%. It's still not as good as the rest of the block in that site, where we've got areas you can see in terms of the yield data there are quite restricted. There's a light sandy hilltop that hasn't yielded well, and an area that we just drained that is still coming to terms with the drainage that hadn't yielded so well either. So two different problems within the same field. What this has shown us by taking this approach, on average, we'd applied 197 kilos of nitrogen. It saved us £53 per hectare in nitrogen costs this season compared to where we were in 2019, which was 55 kilos of N savings. It's reduced our CO2 losses by 257 kilos of CO2 per hectare, but given us a 20% improvement over farm practice of nitrogen use efficiency practice by improving our use efficiency. And for the field, you can see there that we've had a saving of £631 this season, and a benefit of sort of 3 tonnes of carbon sequestration saving. So it really is a tool that can allow us to, without a lot of intensive soil analysis that can be quite costly, use existing tools that we've got to allow the plant to tell us where to apply. The take-home messages that I have from this season then, that obviously climate change and nitrogen price are really focusing everybody's attention to nitrogen use. For some people, there is still a huge lack of trust in terms of soil nitrogen measurements and the cost of that and trusting it. But doing it in a micro-managed approach, what we're allowing to do is actually look at the crop above where the samples are being taken and measure that then in terms of yield as well at harvest. And with lab analysis, we can then do proper grain protein and other aspects and combine that with existing technologies to give us a better understanding of what how we're using technology and getting the best offtakes. It's really allowing us to use the data to make far better decisions. And the big take home this year was really to think about what soil temperatures we've got and how that's impacting our biological conditions and uptake by plants. And yeah, that's my last slide, and I shall leave it there. Thank you very much.
That's great. Thanks, Clive. We don't actually have any questions in the chat at the moment, so I will take the liberty of asking you a couple, if that's all right. So I know you've got your own farm. We'd be quite interested in terms of the variable rate nitrogen that you use. Is that do you use that just on cereals, or are you using that also on oilseed rape?
Yeah, we use that both on cereal, all our cereals, not oilseed rape, and we use it as a sort of a data gathering tool to capture information on all our crops essentially. And
so what sort of, if you're looking to vary the nitrogen rate, what sort of is a typical range or the spread of applications that you end up with on the farm?
I always encourage Dave to try and use it with as much range as possible. We use a solid spreader, so we can, spreaders are very flexible in terms of the rate ranges they can have. So I would always encourage Dave to set the minimum at 0 kilos of N and the maximum at 200 kilos of N. I don't see a lot of point in people making investments in technology that's being calibrated to variably apply nitrogen and then restrict its capability of doing that, because it's typically the extremes where you're going to get the biggest benefit. So having the ability to be able to turn it off in areas where you've got limited plant growth or uptake, where the crop's already stressed and won't need it, is really as important as being able to put a large amount on areas that do actually need it and can respond to it.
Yeah, okay. And finally, I was just wondering, what are you testing yourself on your farm next year? Are you able to tell us?
So now we're just expanding what we're doing with this. So the typical process would be we'll do a deep nitrogen core that will be in the ground that we'll do in sort of early January. That will be analysed. We'll put the soil probes out in the fields, and I need to get on with that. They're sat in the shed at the minute. I need to get them back out, so I've got more data from this season. We will also have some prototype soil nitrate sensors, so we can monitor nitrate through the season, and I'm quite excited to get these so we can compare what's actually going on in real time in the soil. So hopefully those measurements will be able to inform what's going on in the soil, as well as what we do within the canopy, and then look at building on what we've done to really try and target and improve how we can make better decisions.
Okay, thank you. Thank you very much. We'll now move on to our next speaker. I'd like to invite Kate to share a camera, and I'll pass over to you.
Thanks very much, Lizzie, and thank you very much for the invitation to join you all today. I'm just going to try and, there we go. So I'm going to give you an overview of a project that we've been working on for CF Fertilizers. This is a bit of an update on the results so far, and it's a project looking at the effect of little and often nitrogen and sulphur application on yield, quality and fertiliser uptake of winter wheat. And so we're looking at kind of the latest data really on this. So the aims of this project was looking really at, does the little and often timing application of nitrogen and or sulphur improve yield, grain end concentration or protein, or fertiliser uptake efficiency. We used a slightly unusual treatment in that we've used sugar to create some nitrogen limiting conditions. And when I say sugar, I mean the stuff that you put in your tea, so granulated sugar, British sugar, and it's because it's a really low-bar, freely available carbon source, which means the microbes in the soil tend to be quite limited by carbon, so we want to sort of release them from that limitation. And then once they're released from the carbon limitation, in theory, they should become limited by other things, including nitrogen. So we're trying to use it as a bit of a proxy to understand if little and often application is more beneficial under end limiting conditions, so conditions with high immobilisation of nitrogen. It's a bit of a proxy for sort of like where straw is incorporated. It's slightly different, but it's still a very is available carbon source, which is what we're trying to sort of achieve here. And then we looked at little and often nitrogen and sulphur and compared that with standard end timings. So the experimental design, I'm going to report on 2 sites per year for 2 years today. So we had one site that was managed as a feed wheat site in North Yorkshire, another one that was a milling wheat site in Norfolk. And we had the sugar treatment, as I've just mentioned, so that was plus minus sugar. In 2019, we used that as 2 tonnes per hectare at a single timing, but we increased it in 2020 just to really emphasise the effect of that. So we had 2 splits at 3 tonnes per hectare in total. And then the nitrogen treatments that we included were 2 nitrogen treatments, so same total N in all cases. The standard N had your standard 3 splits, your little and often had your standard sort of 6 splits, and then the milling site had an additional 50 kilos of N per hectare at grey stage 37 to 39, and that was a flat rate application across all of the N treatments. Then we also had 3 sulphur treatments, so again they all received the same total, so 50 kilos per hectare of sulphate. Then we had the standard S, so that was a single split, and then we had the little and often S, which was in 3 splits, and a nil S treatment as well. And then finally we had a nil NNS treatment, which I'm not really going to talk about today, but we included that as because we needed that to calculate the N fertiliser uptake efficiency. So when I talk about N fertiliser uptake efficiency, the way that we calculate that is we look at the total N content in that nil NNS treatment. We take that away from the total N content, so that's the whole crop, grain and straw and chaff. And we take the value of the nil NNS treatment total N content away from the total N content of the other treatments to calculate the N fertiliser uptake efficiency. So this graph is, and we've already heard today that we know that the dry springs of the last few years. It's just to really give you an example. It's a pretty typical plot of what we saw in both 2019 and 2020. This is the North Yorkshire site in 2020, and you can see here that we had a very dry spring. So that's just something to bear in mind when we're talking about the results. But it's also just an example of how the timings compared with the rainfall event. So you can see here the 6 arrows represent the fertiliser application timings. The ones with asterisks are your standard rate timings. So you've got 3 splits there with asterisks, and the little and often ones fell sort of roughly in between those. The little and often application rates were generally half of what the standard rates were. So say on the first split, there you'd put 50 kilos of N per hectare on your standard, then that means that the little and often would receive 25 kilos per hectare on the first timing and 25 kilos per hectare on the second timing. So it's always slightly behind the little and often. And the idea for that was that when the way that we normally do fertiliser recommendations is that that standard timing should see it through to the next fertiliser application timing. So with little and often, what we wanted to do was kind of drip feed it rather than putting it all in one go, feed it as it needs it through the season. So that's the way that the splits were designed. So this is just one plot of NDVI. We've got lots of NDVI plots, but this is really to give you a bit of a snapshot of what we saw, the sort of trends we were seeing. So this is North Yorkshire in 2019, and the little and often N treatments were in green here, and the standard N treatments are in blue. I'm going to focus mostly on the N treatments in this, but we will touch on some of the effects of the sulphur and sugar as we go through as well. So at 3 of the 4 sites, we saw that the little and often N resulted in lower NDVI between late Feb to growth stage 37-39. NDVI is quite a nice measure of sort of greenness, the biomass sort of size of the crop. So generally what we were seeing in all of these timings here, that the little and often were generally smaller than the standard timing crops, or a little less green, sort of just not doing as well, always a little bit behind. Now that's perhaps not surprising for these first 2 timings, because that's when they hadn't caught up with the amount of nitrogen fertiliser that they'd received. But by growth stage 37-39, they should have had all have had the same amount of nitrogen, and it should have had time for the crop to take it up as well. So it's interesting here that the little and often was still slightly behind by that timing. So I've got a series of slides now. These are all following a similar format to hopefully make them a little bit easier to follow. So on the left-hand side of the plots here, you've got the North Yorkshire site, and on the right-hand side, you've got the Norfolk sites. All of the graphs are in the same format, regardless of the results, just to try and make it a bit easier to follow. So the standard N again is in blue, and the little and often N is always in green. And you can see here, this is the yield plot, when either with no sugar or with sugar. So there was no significant effect of little and often N or S at this site, but there was a significantly lower yield in the sugar treated plots. And you can see nicely here that the sugar treated plots were much lower, and actually a 0.86 tonnes per hectare drop in yield. So that's exactly what we wanted to see with the sugar. Really, we wanted to make sure it was having an effect on the crop, which it was. At the Norfolk site, though, we did see a trend for an increase in yield by 0.38 tonnes per hectare in the little and often N treatment, so P is 0.059. But no significant effect of sulphur or sugar on yield, and you can see the little and often bars are ever so slightly higher than the standard N bars in that plot. We look at the same data from 2020. So you've got the North Yorkshire on the left again. There's no significant effect of nitrogen or sugar on yield in 2020, but there was a significant effect of sulphur at this site. So actually the sulphur application, regardless of whether or not it was little and often or a standard timing, increased it by 0.93 or 1.14 tonnes per hectare. So sulphur was really important at that site. So it's always worth just making sure that you get your sulphur rates right. At the Norfolk site, we did find, however, a significant interaction between sugar and nitrogen treatment for yield. So you can see here that the little and often bar, the standard N bar here actually with a no sugar was way higher in yield than the standard N bar with sugar. So it's a 1.8 tonnes per hectare difference between these 2 bars. But what was interesting was that the little and often timings, they were not different from these at all. So what we're hypothesising here is that the little and often N prevented a yield loss due to the sugar. And at this site, there was no effect of the sulphur treatment on yield. So that's the yield. If we move on to the N fertiliser uptake efficiency now, so this is the total amount of N that's got into the crop. You can see here that in North Yorkshire in 2019, there was a significantly higher N fertiliser uptake efficiency in the little and often N treatment, from 0.66 up to 0.72 in the percentage terms. So there was no effect, though, of sulphur or sugar at that site. If we move on to the Norfolk site, so just one thing to note with the Norfolk sites for the N fertiliser uptake efficiency, we only measured the results from the sugar treated plots, and that was just sort of practicalities, limitations there. But and we thought the sugar treated plots would potentially have the highest chance of seeing any effects. So you can see here again there was a trend for an increase in N fertiliser uptake efficiency. but it was significant at 0.1 but not at 0.05. And there was no effect of sulphur. At North Yorkshire in 2020, there was no significant effect of little and often N, little and often S or sugar, so just nothing going on at all in 2020 in North Yorkshire. But again, in Norfolk, we saw a significant increase in N fertiliser uptake efficiency in the little and often N treatment. And throughout the range here is generally between 5 and 7% increase in N fertiliser uptake efficiency, but no effect of sugar. However, one thing that was consistently sort of seen between any of these sites with this increase in N fertiliser uptake efficiency is that the concentration and or content of nitrogen in the straw and chaff was generally higher in the little and often N treatments, but there was no effect on the grain nitrogen. So it wasn't getting into the grain, it was getting into the straw and chaff, but it wasn't making it into the grain, this extra nitrogen that we're seeing taken up. So if we have a look now at the grain N, so yeah, no significant effect of little and often N or S on grain protein at either site, and similar in 2020, but we did see that the S application, the sulphur application, increased the grain N content in the North Yorkshire site in 2020, and that was a site where we also saw that big increase in yield. But there was no difference again between the little and often and standard timings. It was just the fact that sulphur was applied that we saw the benefit from. So I've shown you quite a few plots there. I'll try and bring it together with a few slides to sort of summarise. So let's look at the yield results first. So nitrogen treatments on yield, we saw that the little and often N increased yield at one site by 0.38 tonnes per hectare. It prevented a yield reduction caused by sugar application at another site, but it had no effect on yield at the other two sites. For sulphur, one of the four trials showed a yield increase of sulphur of just over 1 tonne per hectare, but we didn't see any evidence that indicating that applying sulphur in 3 splits rather than 1 split had any effect on yield. And then finally, adding sugar quite clearly decreased yield significantly at 2 sites by an average of 0.9 tonnes per hectare. And across all 4 sites, the average yield reduction was 0.6 tonnes per hectare. So the sugar was doing a good job of reducing the yield. So if we look at the nitrogen fertiliser uptake efficiency, so in the nitrogen treatments, we saw that little and often N significantly increased N fertiliser uptake efficiency at 2 of the 4 sites, with a trend for increased N fertiliser uptake efficiency at 3rd site. And on average, the increase rose from about 56% up to 62%. So 2 of those sites, however, were only measured under sugar application, and the 3rd was irrespective of sugar application. The nitrogen increases were generally a result of increased straw and chaff N content though, and or concentration. And use of sulphur fertiliser did increase N fertiliser uptake efficiency at 1 site out of the 4, but it didn't affect, little and often sulphur had no impact on N fertiliser uptake efficiency, so it was irrespective of the frequency of the timings of the applications. And then finally, grain N, little and often N did not affect grain N concentration. Standard and little and often sulphur did increase grain N concentration though at 1 site where the sulphur also increased the yield. So that's where we're at the moment. We do have a 3rd and final year of the data to analyse at the moment, that are sort of waiting to analyse at the moment. So 2021 trials again, we're at North Yorkshire and also down in Torrington near Norfolk. We did add an additional N treatment in this year, which, because of the fact of what we were seeing with the NDVI results, we were interested to see that because the little and often is always slightly behind, what would happen if you made sure the little and often was always slightly ahead? So starting the little and often treatments a week or 2 before the standard treatments. So we've added that in this year with the earlier little and often timing. So we're looking forward to seeing what those results show us. The next question is, could N fertiliser rates be reduced by using little and often N timings? I think that's quite pertinent at the moment, and I think that'll be something that's really interesting to look into. And then finally, what is the impact of all these effects on N2O production and N leaching risks? As Clive mentioned, it's COP26 at the moment, so these environmental effects are quite important. I think it'd be really interesting to see if this additional N uptake efficient or N fertiliser uptake has any impact on those, either positive and or negative. So yeah, thank you very much for listening. I'm happy to take any questions at this time.
Perfect. Thank you very much. That was interesting. So have you got another year to run on this trial?
So yeah, we've got the 2021 trials which have been completed. We haven't yet analysed the data, so they're sat waiting for me to get working on. Quite looking forward to that.
We do have a couple of questions in the chat. UC asked whether the lower NDVI is impacted by the lack of rainfall. I think that's the lower NDVI you were referring to on the Little and Often.
So I think because all the Little and Often and the standard treatments were in the same field, in theory they will have had the same amount of rainfall in both treatments, but it's possible that the fact that the NDVI measurements, the Little and Often timings quite frequently fell when we didn't get rainfall. So although you need a very small amount of moisture to get the nitrogen into the crop, and we think that it did achieve that amount of moisture, it's possible that the fact that it didn't rain when the Little and Often timings were put on, that could have had an impact on the uptake of the nitrogen by those treatments. Okay, and then
Bernard's asked the question which sort of links to that. Do you get less drought stress with Little and Often later in the season?
So I think, possibly, because we got a little bit more rainfall later in the season that year. It might be that interacted, and it's one of the reasons I sort of put that plot up, really, to demonstrate that there might be something going on. It's a hypothesis, though we can't necessarily prove it. But there's sort of, you use the logic that Little and Often might mean that you have a better chance of hitting a rainfall event when the nitrogen's put on, but equally you increase the chance of not hitting a rainfall event when the nitrogen's put on. So it's a bit swings and roundabouts, really. But I think overall we saw from the uptake and the yield at the end, it obviously didn't have any significant negative impacts on yield.
And Ross just wanted to confirm what the soil types were at your sites.
So the North Yorkshire site was on the Wolds, so it was I think it was it was, I'm trying to remember, it was the North Yorkshire site was on the Wolds, and the Norfolk site was just a standard sort of silty clay loam, I think. So
okay. And finally, Paul's asked a question I was wondering as well. He's asked, did you look at the costs and emissions associated with the additional Little and Often applications?
Yeah, so we've got an estimate of the cost. So using NICS to estimate how much, so the NICS guide to give you an estimate of how much it might cost to do the extra applications, it's coming out at about £36 per hectare at the moment, I think, for an extra 3 applications using those estimates, so for the number of times you run over the crop and so on. The emissions, I'd like to look into that. I don't know. That's something that's on my, we still need to work that out.
I think that would be really interesting to look at, and particularly the economics and how that's then being swung with the massive increase in fertiliser price as well. Yeah. We'll just squeeze one final question in. Ron has asked, should you have considered an irrigated trial considering the dry springs variable N application for reliable data sets?
It's difficult, isn't it? We're trying to test it under sort of real conditions, really. So I guess if we're seeing more dry springs, then if it doesn't work under dry conditions, then perhaps it's not the way to go. It would be really interesting to see if there is any difference under irrigated situations. To be honest, 2021 wasn't quite as dry in the spring, so I'm going to see what the data look like from this year. So it'll be interesting to see how that compares.
Perfect. There's always more you'd like to look at, isn't there?
There's lots. There's so many different ways we could look at this. So definitely.
That was great. Thank you very much. I'd now like to pass over to our next speaker. David, are you able to turn your camera on and join us?
Yep, here I am.
Over to you.
Okay. Morning, everybody, and thank you very much for the invitation to talk today. And it perhaps won't surprise you that coming from a liquid fertiliser manufacturer, I'm going to talk about the part that liquid fertilisers can potentially play in improving nutrient use efficiency. And I would say the primary reason why people go towards liquid application is for the sake of accuracy. So if you look at the picture there, which shows liquid nitrogen being applied through a sprayer using dribble bars, then the application is even across the whole length of the boom and no further. One of the main impacts we see with that is around field edges. So looking at the picture on the left, you'll see that you can apply liquid fertiliser evenly right up to the edge of the crop, but not into the margin. But the picture on the right is what we quite often see with granular fertiliser, where there's a device on the spreader to prevent contamination of the hedgerow or grass margins. You end up with an area of maybe 2 or 3 metres at the side of the field around the whole edge of under application. And we wanted some independent verification of what that might be worth. So we asked ADAS to look at their database of combine yield data, looking at the outside combine width on fields treated with liquid and with granules. And in their analysis, across the 50 fields they looked at, the average headland yield penalty was 0.85 of a tonne for solid fertiliser compared to liquid. And the impact of that would obviously be larger in smaller fields because a bigger proportion of those fields is headland. Another reason for talking about liquids is the efficiency. Because of the smaller particle size and the method of delivery, quite often we see, as in these different pictures here, showing farm trials of side-by-side applications of liquid and granular fertiliser, particularly in dry conditions, liquid can often be more efficient and get into the plant more quickly. And here's an example. Placing fertiliser is a good way to improve efficiency. Commonly used in potatoes. This is a trial carried out in North Suffolk on salad potatoes, and this is looking at placement fertiliser put down the spout with the seed, either liquid 720 or granular DAP, both delivering the same amount of phosphate, but the OMEX treatment, because of the greater efficiency, not only increased yield, but also increased the number of salad potatoes from that crop to over the magic million mark that a lot of growers would be aiming for. And that's logical because placed nitrogen and phosphate would encourage root development, which in turn would encourage more tubers to form and be retained. And we see a similar thing in oilseed rape. So this is a trial from the southwest. This is looking at oilseed rape grown with no seedbed fertiliser, and that's the total yield there. And then different rates of different different types of different starter fertiliser applied at drilling. So either straight nitrogen, BAP, triple superphosphate, or a liquid 14-14-0 in the row behind the drill. And you can see that the extra yield, which is the blue area at the top of these bars, from the starter fertiliser in that case, was more than double what you got from the granular fertilisers. Again, I would suggest because of the small particle size and solubility of it, and that produced a net returns of something like 14-to-1 return on investment in the fertiliser. This is looking at liquid nitrogen versus solid nitrogen on grassland. This is a result just in from a series of trials in Ireland this year. And this is comparing calcium ammonium nitrate, which is the form of ammonium nitrate that's used in Ireland, against liquid UAN, both with sulphur, applied after the first cut. And then this is the kilos of dry matter per kilo of nitrogen applied over 22 days. So quite a good measure of fertiliser use efficiency. The first graph is a reseeded paddock, and the second graph showing a larger response is in some permanent pasture. And not only has the liquid fertiliser produced a better return here, but that's with 25% less total nitrogen applied as well. Another way that liquids can play their part is in helping to reduce emissions and losses, which is very much part of DEFRA's focus now. We can expect new rules and regulations on that over the coming years. And one way to do that is to use nitrogen inhibitors with liquid nitrogen. So there's two types. Urease inhibitors protect against volatilization losses as ammonia gas. That tends to happen when fertilizer sits on the surface in dry conditions. Adding a urease inhibitor can reduce that ammonia loss by over 60%. And typically in UK trials, that's shown a yield benefit in wheat of around 0.3 of a tonne a hectare on average, something like a 6-to-1 return on the cost of adding an inhibitor. Nitrification inhibitors, which have been around longer, are different. They reduce nitrate leaching, so loss through the soil to underground water, and nitrous oxide losses from denitrification, which happens when soils are waterlogged. Adding a nitrification inhibitor can reduce leaching, can increase yield by something like 4 to 10%. Obviously, it varies in circumstances. Can reduce nitrous oxide losses by up to 46%, which is really significant because nitrous oxide is a greenhouse gas, something like 300 times more potent than carbon dioxide. and inhibitors can improve NUE by 12 to 15% and enable earlier application. Why I say that is because they're holding the nitrogen in the soil, making it less likely to lose. So you could put more nitrogen on that crop earlier without worrying that it's going to be lost to the crop. And the key sentence here is at the end that inhibitors can be added to liquids as needed. So you don't have to buy the fertilizer already inhibited when you might not need it. You can look at the circumstances that you're applying in. If it's very wet, you might get a risk of leaching. If it's very dry, you might get a risk of ammonia loss, and add them to the liquid as you need to. But nutrient use efficiency isn't just about nitrogen. There's a big issue with phosphate as well, in that applied phosphate fertilizers can be rapidly bound up with free cations in the soil, and that makes them insoluble and unavailable to the plant. This is especially the case in high pH soils or chalky soils. And better use of applied P then can reduce the risk of water pollution from soil runoff, because if unused phosphate is sitting on the surface, then obviously that can find its way to water. So placement of phosphate, foliar application, or protected phosphate can all help to address that. There are other products on the market, but OMEX has one called Polymex, which is a phosphate protector. It's based on a long chain polymer molecule carrying a high electrical charge. So it works like a sponge, attracting the free cations in the soil, protecting the phosphate from immobilization, thereby making it available to the crop for longer. How does that manifest itself? Well, this is an example. This is a summary of 24 trials done with Polymex with phosphate application in potatoes over 2 years. And it shows that the standard fertilizer, or the standard fertilizer with Polymex added, there's nearly a 10-ton increase in yield average there, and a 10% increase in tuber numbers. Tuber numbers, as I said earlier, being influenced by availability of phosphate. And then lastly, I'll talk about foliar application. In case you're wondering, that's a picture of a farmer in the Rift Valley in Kenya making a foliar fertilizer application. And foliar fertilizers are actually more widely used in the tropics, where applying soil applied fertilizer tends to be quite inefficient because of unreliable rainfall. So the advantages of foliar application is that you can bypass those limiting soil conditions and apply fertilizer directly to the leaf, so the plant can get hold of it even though the roots might not be working. You can target it towards the part of the plant that you want to apply the fertilizer to, which might be an ear of wheat in the case of milling wheat, or might be fruit on a tree. And in the case of perennial crops, you can supply fertilizer to plants where the roots are quite deep, so soil applied fertilizer can be less effective. And this is looking at the example of that. This is applications of foliar nitrogen for increasing wheat protein compared to granular nitrogen. So the graph on the left, this is showing untreated, that's the protein level that was achieved. Ammonium nitrate applied at the ear emergence, the standard timing, 40 kilos of nitrogen a hectare, or the same amount of nitrogen applied as a foliar nitrogen at the milky ripe stage of the grain, so a bit later. And in that case, both treatments worked as they should, delivered very similar levels, and more than 1% more protein in the wheat, so happy farmer. But the graph on the left is from the same year, the same trial repeated in Eastern Essex, and you'll see in that case, the ammonium nitrate at ear emergence was much less effective, raised the protein level by about 0.5%, than the applied foliar urea. And the reason for that is because in the Cambridgeshire site, there was plentiful rain after that first ammonium nitrate application. But in that year, 2016, in that part of Eastern Essex, there was a drought all the way through late May and June. So the granular fertilizer didn't really reach where it needed to, but the liquid nitrogen did. So just to round up the points I've been making, I'm aware this is a quick whiz through, quite happy to answer questions afterwards, is that liquid fertilizers can improve nutrient use efficiency. There's a financial benefit because you can get improved crop response to the uniform application, the accuracy, and the availability of that fertiliser. So choosing the type of fertiliser can make a big difference. And there can also be agronomic benefits. So if you use SAP, which is testing the tissue of the plant, and soil testing services and precision application, you can ensure the crop receives exactly what it needs. The plant is then immediately able to uptake the nutrients provided, and you can choose to use inhibitors to best advantage when needed, depending on the conditions, to help retain that nitrogen in a place where it's really needed. And that's me. Thank you, Lizzie.
That's great. Thanks, David. We do have a couple of quick questions in the chat. Liam has asked us a point of clarification. Were the granular fertilizers placed as well?
Talking about the potato trials, presumably.
I think
yes,
some earlier trials, yeah.
Yes, they were. Both types of fertilizer were placed on the planter.
Perfect, thank you. Mechteld has also asked, I'm not sure if you know the answer to this, whether we know whether there's an effect of urease inhibitors and nitrification inhibitors on microorganisms in the soil.
Yeah, that has been extensively studied with DCD, which is the nitrification inhibitor that we use, that's been around for, I think, about 40 years now. So there has been detailed studies looking at soil microorganisms, and the conclusion was there wasn't really any significant effect on the microbiome. They do seem to be particularly targeted at Nitrosomonas, the bacteria that causes nitrification. So that's fairly clear. I think it's less well known for urease inhibitors. There's a number of urease inhibitors out there. They're much newer to the market, and I haven't seen any studies on that go into great detail. I don't know whether you have, Lizzie.
No, well, when I looked at the question, I felt that I was sure that there's work being done on it. I was having trouble pulling that to mind, so I'm glad that you were able to sort of cite those earlier studies. I mean,
what I would say is that urease inhibitors are different, whereas nitrification inhibitors are targeting bacteria. The urease inhibitors inhibit an enzyme which isn't a living organism, so they're not meant to have a direct effect on soil bacteria. But I think the jury's probably out on that.
Yeah, okay. If we've got anyone else joining us that knows of those detailed studies, they can also pop their comments in the chat. Just one final question. Challenge with all research. Michael said all data shown are from single fields and specific years. Do we have other data from multiple sites, multiple years to support the use of nitrogen inhibitors?
Yes, again, in the case of nitrification inhibitors, we've been experimenting with that for more than 20 years, so we do have a large amount of data. In a quick presentation like this, you're obliged to try and make it sort of short and sweet and simple. So I haven't shown absolutely everything, but I'm very happy to share that. And yes, in the metadata, there is definitely an advantage from nitrification inhibitors. Urease inhibitors have been around much less widely used, so still have something to prove in that respect. But initial trials are quite promising, and they were over 3 years. And then in the case of the phosphate trials, there was actually 24 trials there over 2 years. So that was metadata.
Perfect. Thank you. Thanks again, David. I'd now like to invite our final speaker, Dan Kindred from ADAS, to join us. Hi, Dan. Over to you.
Thank you, Lizzie. Okay, so I want to get straight to the big question of how much nitrogen we should be applying, especially given where we are now with the prices as they are, but also having thought about this from a carbon perspective. Because actually, really, if we want to think about how we should be living in a world where with net zero and reducing our greenhouse gas intensities, where nitrogen fertiliser is responsible for about 70% of the emissions from an arable crop, then we really need to be thinking hard about how we can reduce those nitrogens. And actually, it's pretty much the same kind of conclusions you come to, whether you're thinking about price being the driver or carbon being the driver. And so, really, I think we should be thinking about nitrogen as a strategic decision. The most important question that we have is how much nitrogen do I buy for my farm? Then those questions of what do I apply where and when are kind of are further down the line. But that bigger question is how much should I buy? And that's an economic decision, and it's based on the return on investment. You buy nitrogen because You think you buy it, you apply it, you get further yield. And I think in the past, when nitrogen has been cheap, we've largely seen that question in terms of trying to avoid missing out. You know, am I applying enough nitrogen? It's really been the main question that we're kind of thinking about, and not wanting to kind of be in that steeper part of the curve where if you think that you might be missing out on a whole load of yield. We obviously don't want to be applying too much. We don't want to be getting lodging, and we've always been aware of all the environmental side of it. But I think the prices where they are now really bring that into focus. So, but the nitrogen requirement has always been defined as the rate that maximises profit, and that's what all the recommendation systems over the last 50 years have really been based on. And those recommendation systems are all right. They're based on a whole load, I think, hundreds of empirical field trials that give us the answers which are right on average, but they mask huge variability. Okay, there's massive variability in the nitrogen requirements as you see in field. So, but these recommendation systems, I think, provide the appropriate starting point. But what we need to do is then we can improve that with on-farm experience. So actually kind of saying, actually, where on my farm, am I higher or lower than what, or on this field, am I higher or lower than what the standard recommendation would say? There's also the case, obviously, these requirements change as fertiliser and grain prices change. And so we know that if the price of grain falls and the price of fertiliser increases, then it makes sense to be applying less. So given that the fertiliser price has doubled in recent months, what should we be doing about that? So I've said that the nitrogen requirement is defined as its economic optima. So really and all of this is defined by these curves you can see on the bottom. So this is a typical response curve that I've put here, where the optima is in the blue dot. And that's the rate at which, the nitrogen rate at which an extra kilogram of nitrogen wouldn't be paid for by the additional grain yield that you're achieving. And that's really defined by the break-even ratio. So that point is the break-even ratio. So the kilograms of grain that you need to pay for 1 kilogram of nitrogen. So historically, through the 70s, 80s, 90s, that was about 3 to 1, and it was pretty constant. You know, when grain was £100 a tonne and ammonium nitrate was about £100 a tonne. Since 2009, that was changed to 5 to 1 when nitrogen got a bit more expensive, and that was revised. So all the recommendations since 2009 have been based on a break-even ratio of 5 to 1. But we're now at 10 to 1, so that's doubled, and that makes a big difference. We're now talking about nitrogen costing £2 a kilo. So for that, thankfully also the grain price is up. So you can see, and I know whether you can actually sell grain next year for £200 a tonne is a moot point, but it serves a neat calculation here that with nitrogen at £2 a tonne, grain at £200 a tonne, then you need 10 kilograms of grain for each kilogram of nitrogen that you're putting on, and that's what these curves show. So the blue dot here being standard prices at 5 to 1, with the optimum around 200. You move, so that's the point at which that slope equals the break-even ratio. So where the slope there is 5 to 1, you increase that to 10 to 1, then you move down the response curve to the point at which the ratio is 10 to 1. And that is, in this situation is about 50 kilos less. And generally, when I look at these curves, we're looking at applying about 50 kilos of nitrogen less per hectare now than what we're used to. Those adjustments are given in RB209. We've just done some work for HDB, looking at this and kind of formulating the adjustments. There are adjustments in the current fertiliser recommendations that do this, but they don't actually kind of go far enough given the prices where we've got now. So we're now adding that in. That should be available this week, hopefully. But as a rule of thumb, for every increase in the 1 unit in the BER, then that corresponds to a reduction in the nitrogen rate by about 10 kilos a hectare. So obviously you can see the point at which these, in terms of the margin of over nitrogen cost. If you look at the blue line in the middle graph here, then you can actually see that if the amount of nitrogen, the amount of profit that you make is pretty actually independent of how much nitrogen you're applying within 50 kilos of that 200 kgs. Because the response curve is so flat at that point, what you lose in yield. Say if you're below the optima, you gain by saving in fertilizer, and when you if you're applying too much, then you gain a little bit in yield that offsets it. So really, the cost of being wrong in that 50 kilos, if you're plus or minus 50 kilos, nitrogen generally are pretty small. But with the new prices, so in the following, you can see actually with current prices, I did this on £180 a tonne, then actually you are actually still better off given the higher grain prices, despite the higher fertiliser prices. But we're closer to that shoulder. You know, we're closer to that point at which being a little bit wrong, so we're actually applying slightly less than what we really need, is starting to cost us much more, and that's what you can see in this in the third graph here, that lost profit. So I think as we kind of move to a situation whereby we are closer to that curve, closer to that shoulder of that curve, then the costs of getting it wrong are much greater. So the amount of effort we ought to be putting into defining this and getting it right increases. And that's important given the huge variation that we see in nitrogen requirements. So these are the selection of end response trials put together from the last sort of 20 years. And you can see that the range in optima is, you know, so there's plenty of we have plenty of situations where the optimum is actually 0, right through up to more than 300 kgs. And lots of variability there. But most of that is driven by the amount of nitrogen which is available from the soil. So if you correct for that and include the amount of nitrogen that's been available from the soil in the response curve, then you see the graph on the right hand side here, where actually you see the shape of these curves is pretty consistent. You know, they don't change all that much, but what we have is a massive variation in the yield achieved. And whilst there is a slight relationship there between the yield achieved and the appropriate amount of nitrogen to apply, that's not what's driving the variation. You don't get more yield, generally speaking, by applying. You get lots more yield by applying more nitrogen. The fields and the crops which achieve high yields do that whether or not you apply lots more nitrogen. It's other things which drive the majority of the variation in yield that's out there. But so that's our job really, I think, now is to work out, is to get to that. Do the best job of working out which one of these curves we're on our farms, and accounting for the soil nitrogen supply, accounting for the crop nitrogen demand, accounting for the fertiliser recovery to make our best judgment. So as I said, I think deciding what rate is right for my farm is really a strategic decision. So really, we should be using the experience of how we've got on in the past to judge the success of our past nitrogen management to inform our future decisions. So monitoring yields, thinking about lodging, thinking about what's happened on my fields if I've missed a bit, or if I've had where I've had an overlap. Also, the metrics that Clive was talking about, thinking about your nitrogen offtakes and nitrogen balances and nitrogen efficiencies, we can calculate those. And the history of soil mineral nitrogen that Mechteld was talking about, and soil organic matter, measures of mineralisation, all of those can be should be part of our thinking in terms of thinking about how much I need on farm. Make sure we fully account for nutrients available for manures. And then critically also grain analysis. So we're seeing that monitoring the amount of the nutrients and nitrogen in your grain is a good indication of how successful you've been. So if you're getting 11% protein for feed wheat or 12% for milling, that indicates that you're getting your nitrogen management about right. We can also test different nitrogen rates on farm, and this is one of the things that we kind of see as the most powerful way of knowing this, is just actually applying 50 kilos more or 50 kilos less to a couple of tram lines and seeing what the difference is. If you've got yield mapping on the combine, great, but even just seeing the visual difference of that can tell you a lot of where you are on that response curve. So just to come back to that from the grain analysis perspective, we've just launched last year what we call Yen Nutrition, whereby we can do that. So we have a service where you can test your grain nutrients when we're working with the labs, NRM and Landcrop. But as well as getting that analysis back, we're putting that as part of a data set where we can benchmark. So you can see how you compare to other people, a whole community, with taking into account soil types and your soil indices, and what's been applied for nitrogen, but also for all the 12 nutrients there. So if you can find out more about that on the Yen website. You can if you've got samples from last harvest, then you can send them in to us, and we're operating this as a commercial service. We're also now looking to launch some crop nutrition clubs as part of our farm pet project, which is trying to actually really kind of get that around working around agronomists or groups of farmers and actually kind of learn together, and actually be maybe in a similar situation to see how you compare and where you can drive more, and then doing that testing on farm to learn together. So that idea then of testing on farm and doing trials, we had a big project with AHDB 3 or 4 years ago now, we called the Learn Project, where we did this with 15 farms across East Anglia, mostly on fairly heavy soils, arable rotations, but really demonstrating the value of doing this, of just applying. In this case, we actually did 60 kilos more or 60 kilos less on alternate tram lines. And we did that on 3 fields per year for 4 years. So we had a big data set there. So and this graph here on the right hand side sort of shows the yields that are achieved from that on each one of those curves being an individual field and an individual year. And you can see that generally they're flat. Despite whatever the yield level there, the farmers were getting it about right. If they applied 60 kilos less or they applied 60 kilos more, it wasn't making an enormous difference to the yields that they were achieving. So I think for those farmers, at least, they generally were getting it right. There was a self-selecting group of farmers who we were working with there, but I think it shows the value there of actually kind of giving you confidence that actually I can get away with less, and I'm not going to suffer a massive yield penalty. Yeah, so we're also now developing the tools for that, because there's a lot of uncertainties around. It's easy to come to the wrong decisions. You need to make sure you take into account the underlying spatial variation if you're doing any kind of trials like this, which we're now developing in the Farm Pet project again. Sensing and testing in season. So that's what Clive talked about. I think this becomes more important now going forward, where we've got lots of sensors and technologies that can provide us lots of useful, relevant information. But the real question is, how do we actually integrate that into nitrogen decision making? How do I take this data and actually say, well, actually, that means I should be applying for 30, 40, 50 kilos more, or 40, 30, 40, 50 kilos less? How do you get to that? I think we should be thinking about these. There's a couple of opportunities in my mind from that. One is in early spring, we can be thinking about that these technologies actually being an indicator, an assay of the soil N, of how much nitrogen is going to be available from the soil. Oilseed rate, you can do that very easily. You might have 100 to 150 kilos of nitrogen in the crop by February. You know that if that's there, you know you've got that, and we can potentially sense that quite easily now. Later on, it's about checking nitrogen status, and I think we should be thinking about that in terms of where are we on the shoulder of the curve. How close am I to being really deficient? And there's lots we can do with the SPAD meter that Clive's talking about, and all the other sensors. But are we missing a trick by just not thinking about it more simply? And so this leaf colour chart here on the bottom there is from a project that we were involved in India with NIA, with the Syntron project. It's developed for rice and for wheat now in India. But just a simple technology like that could actually be really useful to us, I think, on crops in the UK too. Especially if you combine that with actually having strips in field where you've applied less or you've applied more, so you know what a crop with more or less would look like. Okay, so to conclude, I think generally we shouldn't be too afraid to cut nitrogen rights back where the economics dictate that. This is a plot here on the right hand side from the Yen, from our yield enhancement network, where we've got a whole range of yields. Going from 6 tonnes a hectare to 16 tonnes a hectare, and yes, there is a slight relationship there with how much nitrogen fertiliser has been applied, but it's perfectly possible to achieve very high yields with quite average amounts of nitrogen. It's not the nitrogen itself which is driving the variation in yield. We should be using a range of tools to assess whether we've got our past nitrogen rates right, and grain analysis being a really important one of those, experimenting on farm. And as we get towards using lower nitrogen rates, it's worth taking more care in tracking our nitrogen status. So there's more value from the sensing tools and making these visual comparisons. And lastly, to say that these pressures that we've got now with high nitrogen prices, I think lead us to the same conclusions to where we get to if we think about this from a greenhouse gas perspective. If we think, well, actually in the future we need to be getting away with less nitrogen, actually it's exactly the same questions we're dealing with. Okay, so thank you very much.
That's great, thanks, Dan. This is very topical at the moment, the increase in fertiliser prices. You referred everyone to the report that ADAS had done for AHDB on break-even ratio. Can you just remind everyone where they can get hold of that?
Well, we submitted it last week, and it's going to be hopefully available with AHDB this week. So it's not yet out, but it will be. It's imminent. And we've done that in 2 stages. There's an initial report we're doing now, and there'll be another a bit more detail to that to come in terms of what the impacts might be for timing and particularly for milling wheat.
Perfect. Thank you. Now I can see we have hit 11 o'clock, and I was determined to run to time, so we won't go over. I would like to say thank you to you all for joining, and a particular thanks to our speakers. It was a great way to kick off the week, a really interesting session. I'd like to remind everyone who's joined, if you would like to apply for basis points for joining us this morning, there is a link on the chat that you can use for that. And if there's if any of you have got any outstanding questions or anything else you'd like to pick up, I'd encourage you all to get in contact with our speakers directly. So I will join the meeting to a close then. Thanks all again, and look out for the other events that we've got going on this week as part of Agritech Week. Thank you all very much.